All right. Good morning, good afternoon, or good evening, depending on when you are watching this video. All right, so experiment 2. So this video is going to focus on the calculations, and then I will go over how to calculate just part of this for table 2, and then the calculation remains similar for solutions 2 and 3. Then I'm going to go over graphing. So I'm going to go over what to expect on how to do the manual graph. And then I'm going to go over how to graph from Excel. And I'm going to go over the percent error for the molarity one. Now here, this will be similar to how we did these. So you'll be on your own for this one, since you're going to use the same process. All right. Now here, you should have gotten an experimental result and then the actual values, right? So now for the class, this is going to be on the PowerPoint that's in Canvas. So go ahead and look up your number, right? So if you have number 1, 2, 3, 4, 5, 6, so I'm going to use data that it's not going to be the same as your data, but here I'll just say it's number 6. And then from the PowerPoint, it's the last slide. You are going to get your accepted density. So here, the accepted or the true value is going to be 1.038 grams per mil for my sample, and it's going to be 1.027 molar for my accepted molarity, and it's going to be 5.778% because this is weight by weight or mass percent. So that's what the accepted values are. Okay, so these are our true values. Now, experimentally, we have to determine this density. So I'm going to go ahead and go over that, but I'm going to go over this first. So let's start, now that I have that information and you know where to find it, let's go ahead and start with some calculations. Now, how do you figure out the average density? Well, we have the masses solution here. So I'm going to go ahead and place this over here, and our first one will be the average density. Remember, we pipetted 20 milliliters, right? So to find the density for trial 1, I'm going to take 21.0511 grams. That's from here. And I'm going to divide it by 20 milliliters. Okay, and then I'll do the same thing for density 2. That's going to be 21.0112 grams, and I'm going to divide that by 20 milliliters. All right, so if I do this for my solution 1, I'm going to calculate this, 21.0511 divided by 20.00. I get 1.05256. But remember, there's 4 sig figs here, so this has to be 1, 2, 3, 4, right? So this is more than 4, this is 4, go with the lowest, so this has to be 4 there. Now I'm going to go ahead and figure out this one, 21.0112 divided by 20.00, and I get 1.05056, and again, 4 sig figs, 1, 2, 3, 4 grams per mil. So now I have the two densities, right? So I use these two divided by the volume, and now I could go ahead and get the average, 1.05256 plus 1.05056. Make sure to always put your units. And then I'm going to take those and just divide by 2, right? So if I do that, that plus that divided by 2, I get 1.05156, so 1, 2, 3, 4. So we don't want to round till the end. So now this is the average for, and I'm going to label this solution 1 for my lab report. So now this value is going to go here, 1.05, and I'm just going to round it now, 2 grams per mil. Okay. So that's how you're going to find the average densities for all of your solutions. Okay. So you're also going to do that for your unknown solution. All right. So we'll get to that in a second. But you're going to use this value, calculate the density, divide by 2, use these two, and then finally we'll end up using these two. Okay, divide by 20 for everything. Right, now that's how to find the average density. What about the average percent by weight? This is our mass percent. Well, our mass percent, if I start with my solution 1, because again, I'm just doing everything for solution 1, I'm going to go ahead and let's go ahead, and we're used to seeing it like this, mass percent. That's how our book writes it. And it's going to be our grams of solute over grams of solution, and that's times 100%. All right, now we have grams of solution. That's 21.0511. Okay, but how do we find grams of solute? To find grams of solute, we have to go ahead and start with the mass of salt. So we have 8.3382 for our solution 1 in this example. Again, this is just made up data. All right, so this is, yours won't be exactly the same. So that's our mass of solute. Now, if this is how much NaCl we have, well, we know when we went to make this solution, or when we when we want to get the percent by mass of our sodium chloride, our solute, we didn't use all of this 100 milliliters. Okay, if you recall, you pipetted 20 mils from the 100 ml flask. Okay, so what you did was you made 100 milliliters. If you guys recall, you pipetted. From there, you took 20 mils of this 100 mils, and you put it into a little Erlenmeyer flask two-way. So remember your 50 ml Erlenmeyer flask? So we only want to find the salt in the 20 milliliters. Well, how do we do that? Well, we'll just use the ratio. So here we used 100 mil, right? We dissolved this in 100 milliliters. Remember, if you dissolve anything, you have to divide. And we took 20 mils out. Now this will get us our grams of solute. So 8.3382 times 20 divided by 100. And I got 1.66764. How many sig figs? Again, 4. That's lowest here. 1, 2, 3, 4. And that's going to be grams of NaCl because these volumes cancel. Okay. Now that we have our grams of solute, now we can divide it by our mass of solution. So to find our percent, mass, I'm going to take my grams of solute, 1.66764 grams. So this is our solute. And I'm going to divide it by the mass of the solution. Well, the mass of the solution is still going to be 21.0511. That hasn't changed. So 21.0511 grams, that's times 100%. So 1.66764 divided by 21.01511. And that has to be times 100. So in this one, I get 7.92187. Again, 4 sig figs, 1, 2, 3, 4%. Okay, well that's just one of them, right? I have to do this again because I need an average, right? So you have to take a look at both trials. Well, I did it for trial 1, so just like the density, I had trial 1 and trial 2, then took the average. I have to do the same here. I have trial 1, now I have to do the same thing for trial 2. So I'm going to go ahead and do that now. So I'm going to put this over here. So for trial 2, I know, okay, so let me label these. So this is trial 1. Now trial 2, did that amount of solute change? It did not, right? So I only need to do this part once because I still just used the same 8.3382, right? We didn't remake this solution. So for the percent mass, I'm going to have 1.66764 grams. But now the mass of solution should change, right? So if I take a look at trial 2, it did change slightly, 21.0112 grams times 100%. Okay, so here we're going to have 1.66764 divided by 21.0112 times 100. So in this sample, I got 7.93691% for sig figs. All right, now I could find the average. So our average would be 7.92187 plus 7.93691, and those are going to be divided by 2. Okay, so I'm going to go ahead and do that and divide by 2, so that plus that divided by 2. So in my average now I have 7.92939 for sig figs. Okay, so now there's my trial 2. So, and then here is the average. Make sure I label it, percent mass, mass. All right, now that can go ahead and go into our table. Okay, and I want to reiterate one point. So let me take a look. So our average will be 7.930%. And I'm just going to go ahead and round it here to show sig figs. All right, so let's reiterate the mass percent. Grams is solute. So this will be same for each trial because you should have only done this once. Okay, you should have only made one 100 ml solution. You pipetted a 20 ml aliquot, meaning you took out a small amount. Then you put it into your 50 ml Erlenmeyer flask and got the mass. So the grams of solute, that should be the same for each trial for that particular solution. So then all you have to change is the mass of solution because you've had 2 trials. All right. Then you get the average by adding them up and dividing by 2. All right, so now we have, you know how to find the average density. We know how to find the percent composition. Now the last one is molarity. Notice there's no average because you've only made one solution, right? So again, let me make sure, I just want to make sure this is clear to everyone. So you made a 100 ml solution here, my beautiful volumetric flask. So you made this 100 ml solution, and what you did was for this example, I put 8.3382 grams of sodium chloride, and I filled it to the mark with water, right? So I only have 1 molarity. I don't have an average because I didn't do that twice. I didn't have 2 trials because I didn't make 2 solutions. So how do we figure out molarity? Well, molarity is mole per liter. Mole of sodium chloride per liter solution. So here I'm going to start with the 8.3382 grams of NaCl. I have to convert that to moles, but that's divided by our 100 ml solution. All right, so I need the molar mass in 1 mole here. So if you look up the molar mass should be about 58.44 grams. So that gives us moles. Now what about per liter? Well, I need to convert this to liters, right? So that I have 1,000 mils in a liter. Now I have mole per liter. So I'm going to have 8.3382 times 1,000 divided by 100 times 58.44. So the molarity for this solution, I got 1.4268 molar. And how many sig figs? Well, here, notice, I have 5 here, 5 here, correct? But I'm only using molar mass of 4. Okay, so I'm only using the molar mass of 4. One, 2, 3, 4. Okay, so I have 1.4268 molar. Alrighty. Okay, so that's how you're going to go ahead and find your molarity. So you're going to go through this process for each of these solutions, and you need to show me all the calculations I've listed on here so far. All right, now what I'm going to do, I'm going to fill in the rest of this table to show you how to do graphing. Okay. And then, so we're going to go to graphing next. All right. right. Okay, so now here and again, these numbers are made up. I didn't do this experiment for a lot of years. I just found points that should be similar to yours. So here, what we want to do is we want to graph. Now, when we graph, you're going to have two graphs that you're going to draw by hand, and then you're going to have two graphs through Excel. So two manual graphs, graphing the molarity and your density. Here, a manual graph for your percent composition and your density. So let's talk about the manual graphs first. Well, how are we going to plot these? Well, here are what you're going to use. So now your density is always going to be your x-axis. Okay, so that's going to be your x. Now, I'm going to do molarity first, so this is going to be my y. All right, so here I have an example of a hand-drawn graph. So you need to, it has to be on graph paper. So it has to be on graph paper. Don't write this on your graph, I'm just writing it here for you. And secondly, you need to use most of your page, okay? So you need to use 75% of your page. Now, what I don't want to see, okay, so what I don't want to see is if you have your graph, you have your 3 points all here, and that's your graph. So this would not get full points, okay? So don't only use a small section. Notice you need to have the graph landscape. The graph must be landscape. So that means it should be sideways like this, not portrait, right? Because our goal is to use 75%, and we need it to be landscape in that orientation. All right, now what I want to point out, how you will label. So you need a title. So to get full points, you need a title. You need to label your axes. So I kind of rewrote over this. You want to do this in pencil, right? In case you make an error, you can erase it. This is the only time I'm going to really say, please use pencil. So your y, again, will be the molarity. Your x will be the density. All right? Make sure you have your units. And those should be in parentheses. So here's grams per mil, here's mole per liter. So title, you need to label these. Now let's talk about picking your ranges. This is the hardest part. This is going to be based on your data. So if I take a look at the data, and let me move my calculator over. If I take a look at this data, so I have that this is about 1.052, right? That's the highest. And then the lowest is 1.009. So look at where I started my graph. And I want to pick easy numbers to use, right? So from here to here, in this example, we chose 1 to 1.02 here, right? So then 1.009 would be about here. Okay, so I did not start at 0. I didn't have to start at 0 here. All right. Now, it's appropriate for the y to start closer to 0 because my lowest molarity is 0.4 pretty much. All right, so to make nice units, we chose to do it at 0.3 here. Okay. Now, when you plot these, what these data points are, so this would be the lowest concentration, right? So if I were to plot my x and y, here's my x, 1.009, and the y would be 0.3730. Okay, so then you could just plot the other 2 points the same way. There's your x, there's your y, there's your x, there's your y. And now notice, so I have the 3 points. What you have to do for the hand-drawn graph after you plot those data points, and you don't need to write this on your graph for me when you turn it in. I'm just doing that to show the class. Okay, so again, this is your gram per mil, and then this is your molarity. All right, now what you need to do is you have to draw a best fit line. Well, to draw the best fit line, you need a ruler, and you don't want to connect the points. So you need a best fit line. Do not connect the dots or your data points. All right, so the best fit line goes through the points. So what you're going to do is you want to go, one's going to be higher than the rest. I'm going to do my best here. If I have a ruler, this would be nicer. But here, I would go ahead and draw my best fit line like this. Okay, so there's my best fit line. Okay, so ignore that one in pencil on the bottom for now. Okay. All right, so once you have that, then you are done with this graph for now, and you can go ahead and plot the other graph you need, because this is molarity versus density. So you're going to do the same thing with percent composition. So here, notice density is going to be your X again, but your percent composition has to be your Y. Okay, so two graphs to be drawn manually. Notice here, you have the title. 75% of this graph is used, right? Because this is from a lab manual. This is in your notebook. Here is your axis titles, density, grams per mil, percent composition. Here we can put percent, and I want to make this clear, you're going to put mass percent. Okay, or you can put weight percent. All right, and then based on your data, you're going to make your range. So if I take a look at the density here, the density is similar to before, so I can use similar points. Now the percent composition, the lowest we have is 2. Could I have started with less than 2? Sure, but this just works out better here for the graph, so I can start this at 1. Okay, so I'm going to start that one. Notice the other graph started at 0 because the point was lower, right? But here it's 2%, so starting at 1 worked out fine for this graph. Plot the 3 data points. So here, just to make sure it's clear, the X is still going to be 1.009 for the lowest point, but the average percent here would be 2.160. Okay, so that's the data point for the first. You're going to plot the other 2. Draw your best fit line. Again, if you look at the lab manual, it describes it as you're going to have a point above, 2 points below, and you try to get in the middle of those points. Okay, you're going to try to get in the middle of those points. That's your trend line. All right, now, how do we figure out the molarity from our manual graphs? This is what I'm going to work on next. Well, to figure out the molarity, we need the average density. So let's go back and calculate the average density for our unknown. Okay, so we haven't done that. So I'm going to come back to these graphs. All right, so the last part we left on was molarity. So let's go with our third set now. We need the average density. So this is going to be for the unknown solution. We need our average density. And we're going to find it the same exact way as we did before. So density 1, I'm going to use the mass, right? The mass of solution, 20.6957 grams over 20 mils. And then I'm going to find density 2, which is 20.6480 grams divided by 20 mils. And then I'm going to go ahead and add those and divide by 2. If I add those and divide by 2, I'm going to get 1.034 gram per mil. Okay, so we want to add those and divide by 2. So here, let me just make sure it's clear. This would be 1.035 grams per mil. This would be 1.032 grams per mil. And to get this 1.034, it would be 1.035 plus 1.032 divided by 2. Okay, so here is our average. So now I can go ahead and put it in here, 1.034 grams per milliliter. Okay, so this is your unknown from your unknown data in table 1. Okay, all right, so now I'm going to put our calculations aside and let's go back to our manual graph. So let's start with the molarity. So after you've done your graph by hand, well, how do we figure out the molarity here? Well, with the manual graph, that's why I calculated this average density because that's what I had to figure out. So it's about 1.034, that's about here. Okay, so that's about here. So what I'm going to do, let me find a pen that's a different color here. I'm going to try to find a red pen, or a pink pen at least. I'm going to use my pink pen. All right, I'm just going to use this as a ruler. So it's going to be about here. Let me get all these pens out of the way. And my calculator. And so here, I'm going to just use this as a ruler. You're going to go up to the line. So I'm going to go up to this purple line. And then I am going to go over. So if I go over here, try to make it straight as I can. It's not even, so that's why you do this in pencil. So I'm going to, and I want to do it in pen to show the class. It's going to be right here. Okay, so it's that second line. So it's going to be the point right here. All right, so this is the your unknown density average. So here's your unknown average density. You draw a line straight up and over. So here, that's going to be our molarity, because we want to know what the molarity is, right? So the molarity from the graph, which is on our y-axis, and I'm going to look here and I'm going to say, okay, to me, I'm going to eyeball it. It looks like 0.92. So that dot seems to be about 0.92 molar. Okay, and I could only read, so if that's 0.9, I could only read one more decimal place. So here it's going to be 0.92 from the graph. Okay. Now this graph, we're going to do the same thing for percent composition. Our average is the same, and I'm just going to draw this line here. I already have it in pencil, and then I'm going to draw it over so you can see. And it's this point here. So for the manual graph, and again, this is your average density from your unknown. And if I take a look here, that to me, if I eyeball it, that's kind of like 5.2%. Okay, so here, this is going to be 5.2%. So that's how we're going to get the molarity and the percent from the manual graph. All right, I'll go over percent error in a moment. But here, let's go ahead now and move over to, okay, we're done with our manual graphs. How do we do it on Excel? So I'm going to show Excel, and I'm going to show Google Sheets. So give me 1 second. All right, okay, so now you should see Excel. Now you're going to put the numbers, you can select anywhere. I'm just going to start typing in my columns here. So this is going to be density. This is going to be molarity. Now the densities, 1.057, 1.023, or let me see, I think it was 1.052 is what I had there. 1.023. Let me get my data to be sure. Yep, 1.09. I was trying to go off memory. So molarity is 1.427, 0.7050, and 0.3730. So the same data points that you used for the manual graph. But in Excel, what you're going to do is you're going to highlight these. And then what you can do here is you can insert. And you want to pick the graph called scatter, so the one with these dots. And don't put any lines, so no lines. And you just want to make sure that your density is on your X, which it looks like it is, and your molarity is on your Y. If it's not, you have to go ahead and switch your columns here. All right, now we want to make sure there's a title. So go to Quick Layout, and in here, you can now see once I went to Quick Layout, and I chose this first one, right, it popped it up like this. So I'm going to do it again one more time. So you're going to go highlight it, go to Insert, go to the Scatter, make sure it's the one with the dots with no lines. Here's your charts, check your axes. Now go to Quick Layout on the left upper left-hand corner, and then choose the one with the title and the axes titles. I get rid of this series, and so here the chart title, I'm going to go ahead and just put it in here. So it's your Y versus your X here. So we know it's going to be molarity versus our density. That's fine. Here, I'm going to put molarity. So I'm just clicking on the left-hand side. And I'm going to put the units, mole per liter. The X, I'm going to put density. And it's going to be gram per mil. So notice when I click on it, I don't see it down here yet. I'm seeing it in this top portion right here. All right, so if I click that, it changes it. All right, so now look at how much of this graph is already done. What's missing? I need the trend line. In an Excel, you're going to right-click on the dots. So you want to make sure you right-click. When you right-click, you're going to add the trend line. And over here on the right-hand side, it says display, it says linear. That's the default. It should be linear. And this is going to display equation on the chart, display the R-squared value. Now, why is this R-squared value important? This is our coefficient of correlation. The best R-squared to have is 1. Okay, the worst is 0. So we want this to be as close to 1 as possible. It means our X and Y correlates well with our trend line. Okay, it means it matches it. The dots are almost on the line. If the dots are not on the line, that's bad, because this should be a linear relationship. As your density increases, so should your molarity. Okay, and I notice I misspelled that, so molarity. It doesn't matter. And what I want you to turn in is the graph. You don't need to turn in this portion. Okay, so there's one graph, and I'll do the other really quick. So you have the density here, and the other one will be the percent composition. So the densities are going to be the same, so I'm just going to copy those. Right-click copy, so drag down right-click, and I'm just going to do Control-V for the paste. Now the percent composition, I just get that from my data, so 7.930, 4.024, and here's 2.160. All right, and I'm going to do the same thing, highlight everything, insert, scatter, no lines, make sure your density is on the x-axis, it looks like it is. There's your percent comp, that makes sense, so it should be, our highest point is about 8. Go to quick layout on the left-hand side. Now we make sure we have a title and so on, so I'm just going to type this in, so it should be percent. And again, it's on the upper left-hand corner over here. Even though I clicked here, it's showing up here, composition. And then that's going to be versus density. Going to get rid of the series. Now I'm going to put in my axis title. So this should be percent, make sure I spell it right, percent composition, mass, percent. All right, over here I'm going to click there. Again, it's going to show up here. And again, density in gram per mil. Okay, so just like our hand-drawn graph, you need your title and your titles of everything to get full points. All right, now here are our data points. How do I get this trend line again? You're going to right-click, add the trend line, and then display equation on chart, display R value. Oh, look at that. That's 1, so that's really good. That means the percent composition and density really correlated well. All right, so it's linear. All right, now what we're going to do is I'm going to show this same thing in Google Sheets. All right, so if you have Excel and not Google Sheets, you can just fast forward this part of the video. But here for Google Sheets, what's cool about Google Sheets is that I can highlight everything, and what Google Sheets will do is it will go ahead, and if I insert the chart, it will actually kind of identify, well, this must be a scatter chart based on the data. So it kind of expected it to be linear, so that's pretty cool. Sometimes most of the time it works. Sometimes if your data is not very good, it'll think it's a bar graph or something. But here, it's recognizing it as a scatter plot. All right, so that's correct. So now go to Customize. Notice it already labeled that for us, right? So the only thing we have to fill in are our units. So you go to Series. Then here, when you go to Series, you need to put the trend line here. Then you want to go to the label. Use the equation, and then show your R squared. So there's your equation and your R squared here. Okay, so hopefully that makes sense. Hopefully then when you go to your horizontal axis, So here, how do we want to label this? I'm just going to go ahead and put in my units here. So if I click on density, it'll pop up the title text. So I'll put in my unit there, gram per mil. And then I'll click on molarity. Now it'll let me put in my units there. Okay, and then this graph is done. All right, now let's do another graph, just so you can see it twice. So I'm going to highlight everything. Then I'm going to hit this little insert chart. Okay, great. It's telling me that it knows it's scatter. Go to customize. And it also, by the way, tells you that your X is density, your Y is percent comp. That's what we need to do. Go to customize, go to series. Then again, trend line. It's always default linear, just like Excel. Show R squared. Label, use equation. So now you have your trend line, your equation, and your R squared here. Make sure we have the right units. Gram per mil. Percent comp. Mass, percent. Okay. All right, now these, you're only going to show me these graphs. So what I suggest, some people ask me in class, what do we do with these? Just go ahead and embed them into your report, okay? Or if you have separate pages, scan these separately. You don't have to show me the data. So these have to be included in your report, okay? And I'll be looking for everything that I've shown in the video. All right. All right. Okay, so now I showed you how to use Excel and also Google Sheets. So now, how do we figure out the molarity from our graph? So I'm just going to show one graph on here, and then I'm going to show 1% error. Then you could do the other on your own because it's going to be the same. All right, so from the Excel graph, how do we do the molarity? Now, the molarity from the manual, remember we went up and over? We don't do that. Here, you're going to use your equation from the graph. All right, and then again, you could use your one from Google Sheets as well. I'm just saying Excel, just because I kind of use that as my standard. Okay, so how do we do this? Well, if I'm going to use this equation, well, I still need our average density like we did before. That's going to be our X. So your X is your average unknown density. Okay, and then we're going to solve for Y. And that's going to be our molarity, right? Because that's on our Y-axis. So let me get the calculations page, since you have to write this down in your calculations. Okay, so here's our unknown solution. So I'm going to go ahead and put this over here. Here's our unknown solution and our molarity from, I'll just write Excel graph. You can write it Google Sheets, whatever it is. Okay, because we're actually calculating it. It'll be Y equals 24.57x minus 24.423. So here our unknown value, our average is that 1.034. So it's 24.57 times 1.034 minus 24.423. Okay. So now 24.57 times 1.034. This is 25.4054, only 4 sig figs, so 1, 2, 3, 4, minus 24.423 on this graph. So if I subtract that, minus 24.423, I'm going to get 0.98238. Has to go to the tens place, right? So the molarity with sig figs will be 0.98 molar. Okay. All right. I hope that makes sense. If not, please come to office hours. So now I use that equation, and that's going to go here, 0.98 molar. Okay. So now what's left here is, after you do that for the percent composition graph, now let's do our error. Okay, so I'm going to do one of these errors. The other will work the same way. So now I'm going to label this unknown solution. And this is going to be percent error, the molarity. Okay, so let's go ahead and take a look here. So my molarity, so percent error is our experimental value minus the accepted divided by accepted times 100%. So from our graph, it's 0.92 molar, so I'm going to do this one, minus our accepted. Well, the accepted molarity is 1.027. Divided by accepted 1.027 times 100%. Now to figure out sig figs, so 0.92 minus 1.027. This is going to be minus 0.107. And so here it's to the hundredths, so we have to cut it off there. And it's going to be 1.027 times 100%. This means it's going to be 2 sig figs divided by 1.027 times 100. So it'll be negative 10% with 2 sig figs. Okay, so I'm going to put that decimal there to make sure I know it's 2 significant figures. You could also say 1 times 10 to the 10. Negative 1 times 10 to the negative 10. All right, so here, negative 10%. Then to do the other one, same thing, 0.98 minus 1.027 divided by 1.027 times 100%. Okay, and then you guys can see now how to do that. And you're going to do the same thing for percent composition, but your actual value is 5.778, and the experimental is 5.2. Okay. All right, well, that's, I showed you how to do all of the calculations, how to do all the graphing. If you still are stuck or this video didn't make sense, I hope I didn't rush too much. I'm trying not to, but hopefully that helps. All right, so please come to office hours if you have any questions. All right, you guys have a good day.